I'm the keynote, but I got lots I want to talk about and share, and hopefully get a little dialogue going as well with the audience. So we're here to talk a little bit about debugging web applications, and you're here probably because you've had to debug a web application, and probably inside a production environment. I know I've certainly written some code that has been challenging. I recall an incident. We're in the middle of a ticket sale for one of the artists that we work with, and 5 minutes into the ticket sale, the entire server grinds to a halt. And of course, there's me and the other developer at the time sitting there, basically panicking in this kind of sweat as we watch our web application that we spent so long and so hard to work on just crash. And then, of course, we're tasked with, how do we make this work? How do we ensure that this never happens again? And one of the challenges in a production environment is you don't have Visual Studio. I can't spark up Visual Studio, go to attach to process, find the worker process, set a breakpoint, and start rolling. And so that's one of the big scenarios that they looked at with IIS 7 is not only how do we build a more scalable web server, something that's more secure, but how do we help everyday developers engage more easily within the environment. So part of it was the extensibility model, but another component was saying, how do we make it easier to debug these environments? And it's coming out of practical experience. Every time you call Microsoft PSS, they're actually taking notes there, and they're saying, what are those common scenarios that most of us as developers and users of the systems run into? And then that comes into consideration as they develop the next release. So as we look at some of the tools and techniques and the things that are available to you, a lot of this has come out of feedback from all of you as you've called in and interacted on the discussion boards and Microsoft Connect, et cetera, et cetera. So it's really, you guys that have driven these feature sets, and I think you'll see them and you'll say, hey, this actually makes sense. But there's a more fundamental thing before we get started on the specific tools, and one of those things that, debugging is as much an art as it is a science. And that's something, for anybody who's debugging out there, what I'm going to introduce to you are a bunch of tools, but really there's an underlying process there. And I want you to kind of remember that when you're debugging, first off, all assumptions are out the window. Don't assume anything. You really want to find tools and techniques and references to be able to understand what exactly is going on. So go out and get the facts. And hopefully these tools will start to show you some of the ways to get those facts. I'd also make sure that you don't take the approach of, let's just switch this setting and see what it does and see if it works. And the reason you don't want to do that is you really want to consider the impact of what you're doing. And I've seen this a lot of the time. My background straddles both the systems admin side as well as the development side. And I've worked with my development team, and I've had them say, well, why don't we just check this checkbox and see what happens? What worries me about that, coming from kind of both of those backgrounds, is in the back of my mind, I'm wondering, do they really understand what they're asking me to do? And I've had the experience even dealing with Microsoft PSS where they asked me to run some command on Windows System 32 to reset file permissions. And I say to the tech, are you really sure that you understand the impact? Can you explain to me what's going on? And at the time, I thought, he was saying, yep, no, don't worry, this will work, no problem. And I thought to myself, okay, it's Microsoft PSS, I'll run it. Let's see what happens. Sure enough, he actually crashed my SQL server, and I ended up spending the entire weekend rebuilding my SQL server because the command was actually quite destructive. So when it comes to debugging, everything should be measured, and you should really try and understand, what am I doing? What is my next step? What is my plan? And it's really about trying to take this big unknown and break it down and make it a set of knowns. And again, these tools are really designed to help you get down to that root cause and understand what's going on by providing you facts of what is actually going on within the server. And really they did it through providing a couple of different approaches to it. And there's no one magical tool that you can run and get information. They're exposing a lot more information through these various tools. So we're going to talk about some of those tools today. The first one, really is trying to find out what's going on in your server. So I talked to you earlier about that situation where we're in the midst of a ticket sale and my server ground to a halt. My first thing is what the heck is my server doing? When you've got that kind of call at 3 in the morning and something's happening on the web server and you've got to be able to respond to that, the first thing you want to know is what's going on. And in the past, we've used the tools that were available to us. We'd be looking at Task Manager. We'd run Process Monitor from sysinternals. We'd look at log files. We'd do debug dumps and then spend hours and hours poking through Windows Debugger trying to figure out what's going on. They introduced a few tools after IIS 6 was released, like Trace Diagnostics and the Debug Diagnostics tools that would do some automatic analysis or expose some stuff. And then there's some third-party tools out there that would help you. These are all really great tools, but a fairly disconnected approach. You really couldn't find the relationship amongst all of the various pieces of information out there. And that's a real challenge when you're debugging, especially when you're under pressure. When the heat is on, your application is down, hundreds of thousands or millions of dollars are flowing through your system, you need information that can be correlated for you. And the IIS team thought a lot about that. One of the first things they introduced was the Runtime Status and Control API. And what this was is a way for you to say, hey, what the heck is going on my server at this exact moment? And exposes things like the state of current requests, the state of your application pools, your worker processes. You can plug in, whether it be through app command exe, through IIS Manager, through WMI, and get a snapshot of what exactly my server is doing at this moment. On top of getting the status, you can also have the control side of it and say, I want to recycle the application pool. I want to kill this request. You've got various operations that will allow you to manipulate the current runtime state of the server. And really, it's built on the core objects that exist in IIS. So there's no abstract API that makes no sense and doesn't relate and is all kind of confusing. You're dealing with application pools, worker processes, etc. And it's really, again, a neat way to plug in. And of course, as you'd expect, the relationships within this make sense. Your Windows Process Activation Service will spin off application pools, which spin off worker processes that spin off requests, and also have application domains in play. The object model really is just maps to what IIS is doing, because that's exactly what they're exposing. They're doing a one-to-one mapping to what's actually happening within the system. So let's take a look at what RCSA looks like from some of the tools and stuff. So the first thing I'm going to do is I'm going to actually go modify, because I found it was just too short of a time. I'm going to up my sleep. I've got just a page here that does some sleeping. And it's going to pause the system and simulate a long-running request for 60 seconds. And if you were here yesterday, we talked a little bit about extending IIS and the idea of asynchronous processes. This is not an asynchronous process, and these are one of those potential problem things where you're going out and doing a database call, you didn't make it asynchronous, and it's sitting there just consuming resources. And once you hit a certain point, you're going to run out of threads, and the system will become generally unresponsive. So let's simulate what this system looks like on an unresponsive state, and then turn around and take a look at how we can get that information. So before I do that, I'm actually just going to prep ahead of time here a connection to IIS Manager. This is the IIS Manager 7 that shipped just about 2 months ago, and it's available on IIS.net to download. Allows you to remotely manage IIS boxes. In this case, it's remotely managing my virtual machine. Highly recommend, if you're doing IIS 7 work, that you grab this and load it on your desktop. Saves you from having to hit up the server console every time. As that loads and connects in the background, what I'm going to do is pull up my sleep page, which is going to sit there and simulate that long-running operation. When I go into IIS Manager, there's this icon here under Health and Diagnostics called Worker Processes. And what that does is this gives you the current status of the system, and you can see the worker processes that are loaded. Let me just go back to my page here and just hit continue, because my transport security module is working. So I can see my current app pool, and I'll restart the process in a second, but you notice right out of the gate here, I've got my app pool, the process ID, and some CPU and memory information. In IIS 6, I had to run a little script called IIS app, which would dump where the process IDs were for the worker process. Then I had to quickly open Task Manager, scan down the list, and say, oh, here's actually what that process is doing. And again, it was stuff that was really quite common in IIS 6 to do. They've gone and built that into the user interface so that you can get really quick access to that information. if you plug into the worker process, you can also now start to see what's going on with your particular set of requests here. And again, this was stuff that was available in IIS 6, but really, really tough to find. They shipped a tool after the fact called IIS Request Monitor, and it was a really great tool, except you had to know about it, and you had to download it, and you had to install it. All these steps that were barriers to you actually being able to get the information, where in the heat of the moment when that production application is crashing, you're thinking, I just need to know what's going on. Well, this is great because it's going to tell you what's being called within my server. If I had 100 requests, I could scroll through all 100 requests. Where is it coming from an IP address? And then it starts to expose some really interesting information from a dev perspective, which wasn't there in IIS 6, which is where is it right now in the IIS request pipeline. So you can instantly kick in and start to wonder, hey, is it that custom module that I built, or is it my ASPX page that's causing a problem? You can actually start to get some real facts, real hard facts right away as to where the problem might be. And this is really useful because that scope that you start out with that's this big now becomes this big, and it helps you get down to that root cause a whole lot faster. On top of that, we get some time information in terms of how much time this particular request is taken. So you get some really, really useful data right out of the gate with the request monitor. And of course, this isn't only available in the command line. There's a whole bunch of stuff that's available through the IIS Manager. It's also available through the command line and through WMI. So let me just go ahead and run a remote command. I'm just going to use Windows Remote Shell. I'll just show you what I'm doing here so you can see there is no magic here. But I'm calling off to Windows Remote Shell and simply passing in some credentials, my super secure password, and then I'm just running commands. This is a new Windows Server 2008 feature that allows you to run and execute commands remotely. And again, it's neat because I can do it without having to log into the console. So let's go ahead and remote shell in, and we'll run app command, which is under the C Windows System 32 inet serve folder. And we'll go ahead and do a list request. Now my page will probably have finished by now, which it looks like it has. I've got all kinds of trace information. We'll come back and talk about that in just a little bit. If you're an ASP.NET developer, that looks very familiar. Let's go ahead, rs C Windows System 32 inet serve app command.exe list request. And what's going to happen here is I'm going to go ahead and call that command remotely. And a lot of that same information that I saw inside the IIS Manager, I now get through the command line. The point here I'm trying to make is that the information is really, really accessible. And in the past, you used to just have to say to your systems guys, click here, click here, click here, read to me what's on the screen, and then tell me what's going on. And then I have to go back and interpret that. And of course, it's like playing the telephone game. They may forget a detail that's actually really important to you, or they may mispronounce it or tell you the wrong piece of information. With the APIs and through the command line tools, you can just go in and get that information remotely and get the real information as part of that whole process. So you could create essentially a little tool that says, send the current IIS state to my email account and tell the systems guy, just run this application and it will send you the details, the snapshot of what's going on at that exact moment. So you're getting real accurate data straight from the source. On top of that, we can also do things like plug into WMI and to start running some of that, getting some of that information through the various pieces of programming interface. So I'm just going to cut and paste a good old script here in because nobody wants to see me type here. But let's go ahead and take a peek at my remote desktop. Let's wait for it to connect here. So I've just got Windows Web Server 2008. It's the ultra cheap, ultra cool edition of Windows servers built specifically for running IIS. So I've got a script here that simply it's good old VB script, and it's just going to connect to the WMI instance. It's going to plug into the web administration namespace. That's the WMI provider for this whole process. And I could have done this remotely. You can do WMI remotely, and you don't have to worry about having IIS 7 installed on the machine that you're on. So you could be on Windows XP and troubleshooting a Windows Server 2008 with IIS 7. It's going to simply cycle through the worker processes and output the information of the worker process. Again, getting me essentially the same bits right through WMI. So let's go ahead and file save, and we'll change that to c:/request.dbs. Let's go restart my load here. I got to run it on C script. Oh, I got an invalid character. Probably a crazy smart quote. I'm not going to spend time debugging here because it's probably installed a smart quote somewhere, and it'll take me a while to find that, I'm sure. Anyways, you're going to get the same information as part of the script. It's going to expose the requests that are running, and again, all the same pieces of information. The message here really is that what I get in IIS Manager, what I get out of App Command, what I get out of the programming APIs is exactly the same. There's no disadvantage or advantage to using anything. Everything's accessible through every avenue out there, and I think that's really a key thing for us as developers, is that our system admins are empowered with exactly the same information that we have, and allows them to make some intelligent decisions around how to best manage the system. So that's some of what RCSA is all about, and what I didn't show was some of the control stuff, but essentially just in the same way that you can go and grab information, you can also execute various stop and start and recycle commands against the same pieces of information. From the system admin side, going through the web console, it's just like IIS6, right-click application pool, recycle. It's actually using the RCSA bits under the covers to make that happen, and likewise with app command. One of the other things that they worked on in IIS 7 is expanding the amount of HTTP substatus codes. So if you've ever had to troubleshoot a 401 or a 403 error, chances are it wasn't the 401 that was actually the big indicator of what was wrong. It was the 401.1, .2, .3, etc. The substatus code that actually told you this is the type of problem that you're having. Well, they've gone and expanded that a little bit, partly because of the architectural changes here. And so the stuff that used to come up with URL scan under IIS6 coming out as 413s or 414s have now become 404 dot codes. So what's kind of odd and interesting here is that when URL scan or request filtering kicks in, the file's actually the file may actually be there. It's not really a file not found. But what we're trying to say is to the rest of the world is, hey, your request was not found. It's that security by obscurity thing. But oh, the way, here's a hint as to why it might not have been found, and whether that be you put garbage in the query string, your request is too long, etc. They've also expanded the 500 errors, and I've got a typo there, but 15 to 20 is for a bunch of the URL authorization pieces. And again, as ASP.NET developers, we had URL authorization for years now. They've just now gotten that into IIS 7 as a whole. So if you're doing ASP content or static content or PHP, URL authorization is now baked into the platform as a whole. And then finally, 21 to 24 for any integrated pipeline-specific errors. So they're just new codes to watch out for. There's references online in the documentation, as well as what you'll see in a minute, the detailed status errors that tell you a whole lot more about those particular errors. But just be aware that there are certainly some new status codes out there. Detailed error pages. Wow, this was like the best thing they could have done from a day-to-day administration perspective, because if you're working with whether it be IIS 6 or 5 or 5.1, you've probably seen the white screen that says, call Microsoft product support, and then here's like a little blurb of an error message. And of course, you sit there and scratch your head. This 401.3, it says invalid authentication, but my authentication is working. Like, where do I go from here? There's got to be more information out there. And of course, you hit F1 for help, and there's no help available. They really, they sat there and said, hey, we actually have a lot of information, and it exists here in Microsoft knowledge base articles and documentation. The problem is finding it. So why don't we bring that information forward? Because past history and experience through PSS has said that every time a 403.4 error comes up, chances are it's one of these 5 scenarios, and here are a couple things that you can try. And so they bake that into the error pages so that you're able to get some actual real information in terms of what's happening and take some corrective actions. So again, it's empowering people with bringing the information to the forefront so that they can react faster, especially under those high-pressure situations where you don't necessarily have time to sit there and Google around to try and figure out what's going on. We're going to take a look at those in a second. The other thing is custom error pages. And again, as an ASP.NET developer, we're used to custom error pages and being able to do a bunch of things with that. In IIS 6 and prior, all you really had to do had the ability to do was to say, point it to another file. You really didn't have a lot of flexibility. And so they've started to bring forward some of that ASP.NET functionality into the rest of the IIS environment. One of the things that's net new is language-specific errors. It's that realization that, hey, not everybody in the world speaks US English out there. There are people that speak French and Hindi and all these other languages, and we've actually got to provide error messages that people can actually understand. And so what happens is that there's the request, when you make an HTTP request, your browser will sit there and read the operating system and say, what language am I working in? And it'll send this accept language header as part of the request. And it simply says accept language : and then the language and the nationality if there's a specific dialect of that language. And then IIS will interpret that and take a look at it and say, hey, what languages do I have on file? Oh, I've got a 404 that's in French. I'm going to go ahead and send that along. Likewise, it will fall back. It says if I don't have that specific error, it will say, okay, I'm just going to go back to my default one, which is US English by default. But again, it's really neat because it's that idea of globalization and localization within the underlying operating system. What was a real kind of interesting for anybody who got into ASP.NET and started doing error pages, you probably noticed the little behavior where it would do that redirection of the error page to a 500.htm/error original path equals. And of course, your users would sit there. You create your 500 error page and say, please try again in a few minutes. So the users would sit there and hit F5, 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 except it actually wasn't trying again. It was just displaying the error page again and again and again. And of course, that would result in a frustrated call to help desk. At help desk, you'd say, oh yeah, just go into the URL, delete, 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 and then now retry. Just a really big mess. And they kind of realized that and said, ooh, that we kind of messed up there, and we didn't make that as clear as possible. So they've given us another option here, which is replace the response with the error page. And this is more what I think we're used to, or what we've been looking for, is that if I'm going to make a request to foo.aspx, and foo is going to fail, instead of redirecting somebody to the 500 page, I'm just actually going to display the 500 error page so that somebody actually can hit F5 and truly go ahead and retry that request. So that the way that works is simply is custom errors. There's an attribute there that you can look up that you just say, I'm going to do a response rewrite or redirect. A few things to know about custom errors. That when you're implementing it. First off, delegation is off by default. In other words, if you're going to override the custom errors on the server and you want to be able to allow your applications that run on various websites or various virtual directories, and they want to be able to configure specific sets of custom errors for their application, you're going to have to enable that because it's off by default. It's that idea that I don't want people really changing the way my server behaves when I want to serve up a file not bound. So just be aware of that. Also in classic mode, and this is important for all of you folks who are migrating from IIS 6 up to 7, and you're not ready to make that leap to IIS 7, you got to make sure that your ASP.NET errors are synced up with the IIS custom errors, because ASP.NET will override IIS, and I'll show you an example of that just in a few minutes here. So let's go ahead and take a look at what some of these pages look like. Let's go ahead and pull up HTTP web server /bar. So this is one of those detailed error pages at work here. And what's kind of neat about it is actually I've got real information that I can action on. First off, I get a detailed error that tells me at what point did this thing fail. So it's that request pipeline. I can see it failed at authentication. So this can't be my ASPX page. because it didn't get down that far. It also tells me what file or what handler it was going to go execute, in this case, the static file. And here's some other useful information, especially for those authentication errors. What user do I think I'm running as? If you've got authentication misconfigured, or it's trying to do some sort of Kerberos sub-authentication, et cetera, it's really useful to know what context was I running under. And again, in the past, you could find that information out, but boy, was it painful. It was multiple steps. Now they've just kind of brought it to the forefront for you. Where the knowledge and the interesting bits come into place is it starts to tell you, chances are it's one of these couple of things that are causing your problem. And here are a bunch of things that you could do to try and fix that. And again, it's all stuff that existed out in the information ecosystem. You just spent 6 hours trying to find and correlate all this information and grok it off all the news group postings and the forums postings and the support KB articles, et cetera. And on top of that, they have linked off to some of the common KB articles for a given problem. So really a great way to get access and make an action right away. In this case, it's the exact first cause. I just turned off all the authentication protocols on the particular problem. Let's go ahead and take a look at how ASP.NET responds. So I've got my big red button that you're never supposed to push. And look, hey, ASP.NET actually responds. So here's an example of ASP.NET still taking precedence over. So if you've got those applications, you've built some work around error handling, you don't have to worry under IIS 7. It's still going to totally respect that. And the great thing, again, as if you were here yesterday, if you don't like the way it does errors, you can replace the module entirely and write your own error handling module yourself. Everything here is replaceable. And I think that's certainly a really nice feature as far as getting full control over the web server. Tracing is something that existed in IIS 6 and 5 and previous, but was really never well exposed. It was only used in the most advanced scenarios because you've gone through all the methods. It's not, something's not displaying an error message, but it's not really responding, and you can't quite figure out why. We actually had a problem earlier in the year where we couldn't figure out why one of our SAPI filters wasn't running. And of course, there were no errors in the event logs about why it wasn't running. We know it was installed. It was in the SAPI filters list. And we were just totally stumped at this point as to why 3 out of our 4 servers in this one particular environment just weren't executing this environment. It took us running the trace logs to realize that it was hitting an access denied and skipping over all the SAPI filters altogether because IIS just wasn't bubbling up that error. And so that's tracing really is that idea of telling you what is going on. It's not necessarily about saying there's a particular problem here. It's telling you the entire process that it followed up to the point of an error or just completing that request. And again, when we talk about getting the facts for debugging and figuring out what is going on inside the web server and what's happening, this is a great way to get insight in terms of how it's working. And it's actually been in Windows for quite some time. It's called Event Tracing for Windows. And what they simply did in IIS 7 was expose it. They said, hey, we've already built on top of this great tracing infrastructure. We're not going to go reinvent the wheel and add yet another tracing infrastructure. We're just going to expose that a little better and then start to educate developers out there into how to build their own trace event providers and consumers and so on. And they've actually used it under the covers in a number of the technologies. The way it works, though, here's kind of your basic architectural concept, and you'll find it's actually quite simple. You've got your pipeline modules that are going to, let's say an HTTP handler, an HTTP module. It'll come alive, and it will register for a trace event and say, hey, I'm going to send these couple of events through. And as it sends it through, the trace consumer on the other side, and this could be event tracing for Windows, failed request tracing, your custom debugging app, it's going to sit there and read the configuration and say, I'm expecting events from these places, and then it's going to listen for the event and then output it. It's a fairly simple publish, subscribe type model to the event sourcing. And the great thing is the consumer, you can read the configuration and decide which ones you want to listen to. You don't have to listen to all of them. IIS itself actually raises over 300 plus events. So that idea of selective listening is really quite useful. So you can build a whole set of tracing infrastructure around your application and then just expose and retrieve that information and pull that back and do something with it. So let's actually go ahead and take a look at what it's like to wire up some event tracing. So I've got this transport security module that we were working on yesterday, and I commented out some stuff that is put in earlier. So the first thing we need to do when we're hooking up our custom module is define a trace source. A trace source simply is, it's like a category. It says, you know, hey, if I'm going to go listen for events, I want to listen from this particular source. I called it TS status. You can call it whatever you want. This is what I'm going to use on the other end to say I want to listen for events from this particular source. Hence, it's called the trace source. Once I've got my trace source open, all I need to do is actually start writing to it. And to do that, I can go ahead and call a variety of different events here. I can call a variety of different events here. It's not going to let me zoom in there, unfortunately. But I've got trace event, trace data, trace information, and trace transfer. And what that's doing is saying, you know, there's different levels of information I want to expose. So I may just want to expose a trace event where I say, here's some information, get it out. Or I may want to expose an entire structure of data to say, oh, and here's the request structure that I got back from the web service that I called, so that I can do some real-time debugging on that information. I found this, you know, again, quite handy when you're dealing with, let's say, a third-party web service like a payment gateway or you know, a fulfillment partner or some other external business partner. You're calling their web service. You want to see, you know, what did you get back so that you can figure out why the application is responding in the way it's doing. And you can choose to then, on the consumer side, pull that information or not. Once you go ahead and call the trace event, as an example, it's going to go ahead and allow you to consume a couple of different types. Again, I apologize for the font. IntelliSense won't let me blow it up much bigger, but you know, there's a bunch of the more common ones like start, stop, critical, error, information, warning, verbose, and this allows you on the consumer side again to filter out again. So you know, as a developer, one of the things I try and recommend to people to do is write out verbose events where you think you would need to know information when something crashes in production. So if I'm doing an if switch, and I'm going to, you know, 99% of the time I'll go through the first part of that if block, but in the else block, that's really a rare circumstance. I'll probably trace out the else block so that if I run into a problem in production, I can turn on tracing and see, did it actually run through that other scenario that's not as common. Likewise, if I'm running a switch statement, I may trace out which of the case elements that went through. So again, I can just follow logically and figure out where that line of code went in production, because I can't hook up Visual Studio. I can't set breakpoints and expose all that information. So what we do here is simply apply the trace event here, start. There's event IDs, and then just a random string of data of whatever you want to expose. And you know, there's format conventions. If you look at the IIS modules that you can follow, you don't really have to follow them. You just really, whatever's going to be useful to you. So in this case, I set an event ID of 0, and I just said starting the begin request event handler. And likewise, on the back end of it, I've gone and applied the end begin request. Now, a little tip and trick, if you want to be able to understand where you know, things have gone wrong from a tracing perspective, let's say exceptions thrown, etc. What I do sometimes as well, I use the try finally catch block to get some information. So if I do try and then I do a finally, what I'll do often is I'll actually do my trace event of a start here, and then in the finally I'll do my trace event of an end. And what's actually kind of neat about this is even if I throw an exception here, I'm actually going to know that at that point that exception thrown, it then exited the method and then went on from there. Because I might have a method upstream that catches that event and does something with it, and I'm not going to necessarily get my trace end. So without doing this, what you'll get is trace start, the exception throws, and it goes back to the parent method that called it, it catches and do the exception. You never get that end component because it threw an exception before the method. So I like this pattern to do tracing with, because it ensures that I'll always get the end on the other side of the particular event. So let's make something useful with that. Let's go ahead. We'll build it. I've actually already got it up on the server just to save some time. So let's go ahead and take a look at the particular web config now to wire that up and what that might look like. So let's go to web.config. And again, it's using the native stuff in the .NET Framework. There's nothing here that isn't already in the .NET Framework 2.0. So you're not reinventing the wheel here. And today, if you're using things like Enterprise Library, Log4Net, etc., you might want to consider just taking another look at system.diagnostics. There's really a lot of emphasis around how to use what's already there as opposed to reinvent the wheel. So the first thing we're going to do is wire up the IIS trace listener. And what this is going to pipe to an SMTP to send mail. You could have it go to a SQL database, a text file, etc. And the next thing we're going to define is the source and the switch. And we don't actually expose any of the switches, but you could actually configure tracing one step further with these random arbitrary switches. Really, so what I want is the source. So I'm saying, listen for everything coming from TS status, and then output it through the IIS trace listener. So let's go ahead and save that. And then what we're going to do is pull up the event tracing for Windows as if it were in a live production environment, and use a little tool called Log Parser to do something cool with. So let me just pull up my window here. And let's go to the Log Parser folder. How many people here have used Log Parser? I'm just curious how, or have heard of it. Has anybody heard of Log Parser? No? So what Log Parser essentially is, it's SQL for log files. It allows you to take, let's say, a 600 meg log file and find some really interesting bits inside that log file without trying to open it in Excel or a text file, doing a control-find. You can do essentially a select statement on a log file. You can also do a bunch of other stuff like conversion. We've used it to convert Apache logs to IIS web logs. You do input filters and output that data. It's a really, really neat tool. It's actually a couple of years old, but it's still very, very relevant in terms of the environment. And you'll see here what's necessary to get it working. So the first thing I want to show you is the query providers. And what this is if you're not sure about what log providers are out there, you can actually just do a query providers and get a list. And you'll see the list here in a second, and I'll point out a few of the kind of key providers that you should be aware of. Takes about a second to run. There we go. And so here's an example of all the different providers out there. You're going to start to see the IIS stuff here. So ASP.NET Events, IIS Active Server pages. So if you're doing old ASP code and you want to see what's happening from a trace perspective, there's a bunch of other IIS stuff around the web server, and then a whole bunch of other Windows bits that are plugged in as far as providers of things that you can get some information of. So what we want to do is we actually want to just go ahead and take a look at ASP.NET. So we're going to use logman, that's built into the operating system, and we're just going to give our trace an arbitrary name, let's say Dev Summit, and we're going to say, give me all events from ASP.NET events. We're going to grab all the flags of everything, so 255.5, ETS RT. So ETS is the event tracing system, and RT is in real time. The other thing you can do is have this output to a file, take that file offline and analyze it. But what I really want to show you is what log parser, some of the really cool things that you can do with it. So I'm going to do a select star from Dev Summit, so that's my trace session. And then I'm going to say it's coming in through event tracing for Windows, and I'm going to output it to a data grid. And this is really quite cool what it's going to do. Now to actually make this happen and do something, I've actually got to go back to my server and make a call here to the system for it to output. So what I've got here is event tracing for Windows, just outputting it to the screen arbitrarily. Let me just blow up the font here, make it a little easier to see, and I'll output all rows. And so what this has done is it's walked me through all the various trace events of everything that's gone on and provided all the data out on the back end for this particular trace that's going on. So let's go ahead and expand this out here. And if we scroll down here, we should see our particular module run. That's the transport security module. Oh, there it is. So there we go. So for the URI welcome.png, my transport security module ran, start, and then it passed off to another module called session helper module, and then continued on throughout the request. So I can actually see real time what's going on within the environment. You probably won't want to do the live log screen if you're doing it on a production server. You'll probably want to output it to a file and then have log parser do this sort of output later on. You could also export it to have it convert to an Excel file and all of these other fancy formats. So that's log parser in a nutshell. There's a whole lot more there, and I really encourage, if you're doing any sort of production debugging, it's one of those tools that you really need to take a look at, because it'll help you comb through the information fairly quickly and easily. The other thing that's built in is failed request tracing, and this is for those times where you're not quite sure when something's failing. So let's say you've got somebody's called you up and said, you know, this request is taking too long, but you're not able to reproduce it. It works on my machine. You know, it's that famous statement. Oh, it works on my machine, so it's got to be you. Failed request tracing deals with those scenarios by saying, I know there are these conditions under which something may cause it to fail, and those conditions can be either certain types of content, so we know it's ASPX pages only, or we know it's JPEG images, or we know it's a certain HTTP status code that might be thrown, whether it be a 500, a 404, a 403.5, a 200, etc. The amount of time that it's taken, or a variety of other different elements. And so it allows you to capture that information and pull it back and save that, and we'll take a look at that output in a second. Underneath the covers, if you're using ASP.NET with failed request tracing, you can pipe some really interesting information in there, and it's exactly the same thing as what we just built for the trace listener, using the system.diagnostics infrastructure and hooking it up to the IIS trace listener, and that information is going to get picked up as part of that. And I'll show you that as we dig through the demo. If you're going to do this on pages, one of the things to note, for any of the page information to show up there, the trace directive must be on the page. And so it's just one of those things where it helps to not overwhelm failed request tracing. And so the way this works is that you do trace equals true as part of the page directive at the top. And then throughout the page, you can do it just a trace.write or trace.warn and get data into that page. So just a little kind of catch there. If we're going to use some of the CGI-based environments out there, like PHP as an example, you should be aware that event tracing does not work inside your PHP application. And it's simply a function of PHP hasn't exposed any hooks to event tracing for Windows. So if you want to go out there and write a module for PHP that calls back through C++ or whatever you need to build PHP and hook into event tracing for Windows, you absolutely can. In fact, I think it'd be a really great thing to see published out there within the community is some sort of PHP extension for tracing for Windows. So what you'll find is that event tracing, and again, some people are confused about this, but you'll just see it up to the point it runs the PHP engine, and then all the events after the PHP engine, because really it's just a big black box to it. But again, there's opportunity there through the extensibility of IIS 7 to be able to get some information, or to build a particular module. So let's take a look at how event tracing happens within the scope of a server here. So let's go up to the server. Let's find our failed request rules. Again, the idea is that sitting here under health and diagnostics, and if you don't like this module, again, you can rip and replace it or just choose not to install it. Let's go ahead and I'll just remove my existing rules so I can walk you through how to build one. The first thing it's going to do is ask you what type of content do you want to go and query for. In our case, we'll say all content. The next thing it's going to do is give you some conditions under which you want to dump. And again, it's about constraining. So you could start with a trace rule that's this big, and you could start to narrow it down and reconfigure that trace rule till you get down to the point where you find the scenarios under which it's happening. One of the notes on the screen was that you only get 50 failed request logs at a time, because they just don't want to fill up your C drive with all kinds of logs. You can of course modify that, but it's that idea that you don't really want this running on every request because it will take some CPU cycles. Let's just take all good requests, and then then continue on from there. The next thing it's going to do is expose a bunch of those providers. These providers were all those trace providers that we looked at before. They've just cut out all the non-IIS stuff and exposed all those IIS-specific bits. And so you can go into them and change the verbosity level of any of those so that you can get the appropriate amount of information. Because verbose on everything tends to be overwhelming, as you'll see in a minute. You get lots of information. So let's go back to our web browser. Let's go ahead and run our exception generator, have it throw an error. Let's go back and run sleep.aspx so that we get some activity going. While that's running in the background, let's go ahead and take a look at what of these failed request logs will look like. So let me pop open Windows Explorer here, drag my window back across, go to inetpub, go to the logs folder, and the failed request log files. And again, that's configurable. You can have it go to a D drive. In fact, that's just a general recommendation. All log files should go to anywhere but the C drive so that you don't accidentally fill things up. Then you get these fancy XML files that will start to appear here. And what's really quite interesting about them is that this is really all the data, and they've applied an XSL style sheet to actually make it a little more readable. If you actually look at the data, it's actually quite well structured so that you can process it from an automatic perspective. So if you want to write something that auto-processes failed requests, it's really just XML that you can sit there and query and do XPath queries for and all that stuff. But they've built a fancy style sheet to make it look a little easier to run. And what it's doing is it's giving me the list of everything that's executed. And again, I've got it on verbose for everything. And you can see there's 202 events that were registered at the trace level. I can go over to my custom, sorry, it's not in this one. On one of the other ones here, I've got the actual the module that we had traced out from before. Here it is. So I can see that if I go and view the trace here, this is my my transport security module, and there's my message appearing here. So I can, it can write all of its events as part of this, and that was event number 50, and it took practically no time at all. But you can start to as well here see times of things executing. Again, really quite interesting from a perf perspective. If you've ever had to do performance troubleshooting in a production environment, you know it's certainly not easy at all. Here you get a really quick assessment of what's taken the longest to execute. You've also got a compact view that makes it a whole lot easier to find out what's going on. In this case, an exception was thrown, and it's noted that here in the module level, but then it's also given me the output that threw back, which includes the entire stack trace. So really quite useful information. With this file, I can at least have a really good idea of what's gone on and where something went wrong, so I can start to look inside that particular module. So when it comes to production debugging, you can see there's really a bunch of tools there that are accessible to you to provide you access to information in a really straightforward manner that correlates all that information together. Again, a lot of this information existed in previous versions. It was just disconnected and really tough to pull together. In this release, what they tried to do is expose that in a meaningful way where you can draw some conclusions. There's a couple resources I want to point you to. You've, of course, got IIS.net if you haven't been on there, and some great articles starting to show up there. But if you haven't seen the Microsoft.com Operations Debugging webcasts, they're not all about IIS 7. There's a lot about IIS 6 and prior. But they really do, this is like level 3, 400 stuff. They really dig into how do I debug a memory leak in production. And they'll take you through WinDebug and some of the IIS 6 tools and really show you how it's done. I was really, really quite impressed by the level of knowledge here. This is stuff you won't find in the documentation. And it's real-world stuff. They're talking about real-world events and how to actually dig through with the tools and get to the bottom line there. So I really highly recommend connecting up with those webcasts if you're doing any sort of production-level debugging. And even if you just want general knowledge of CLR internals, they certainly expose things like garbage collection and tell you a little bit about that. So you can find that at shrinkster/xx7. I've saved the big long URL for you so you don't have to remember that. And then the IIS SDK is documenting a bunch more of that stuff. So with that, I'm pretty much wrapped up a few minutes early. So I'd like to let you know I am talking again twice more today. But really what I want to do is, if you've got any questions, if you've got any thoughts, ideas you want to share, let's anybody have any questions on production debugging or scenarios that they've had, some war stories of scenarios that they've had that have caused them great pains. Any questions? Oh, over there, yep. Yep. So let me restate the question and see if I understand it. So you've got a remote server, you don't have access to IIS to control it, but you've got a virtual directory where you're hosting an ASP.NET 1.1 application, and it keeps getting switched to 2.0, or is it 2.0, it keeps getting switched to 1.1? Yeah, developed in 1.1. Yep. 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 Okay. So it should be 1.1, it's getting switched to 2.0, and you think it might be security patches? You might actually be right, it might be security patches. So there's a little thing here, and we're actually going to talk a bit about it in the migration session. There's ASP.NET_regIS that you run a -I, and that re-registers ASP.NET. I've seen this before in IIS a lot, and it still does it actually a little bit in 7. It goes and resets the version of all the applications. And causes you a problem. So anytime, if somebody's running ASP.NET_regIS on that server, that will absolutely go through IIS and it resets everything. And it's just a real nightmare under IIS 6 because you've got to go back and change the version. In terms of what you can do to get around that, not a whole lot in IIS 6, unfortunately. That's actually the nice thing about IIS 7, the application pool. You can enforce the runtime version as part of the application pool setup, and you can do that all in XML configuration. So you've actually got a lot more control in IIS 7 around that particular thing, but in 6 it's pretty much, it's probably ASP.NET_regIS. I've seen that run by applications that install stuff. They just assume, hey, ASP.NET isn't registered. I'm not even going to check, I'm just going to run the tool, and it's just a real pain in the butt. But yeah, it's probably that tool that's overriding it if you're looking for a potential. And it could be a security patch, it could be some other third-party app that's running it. The Microsoft Community Starter Kit from ASP.NET 1.1 will do it. There's a bunch of apps out there that just automatically assume that ASP.NET is not running, and it's just bad design. They should do a check first as opposed to blindly running the tool. So, great question. Any other? Oh, yep. Sorry? Any benchmarks in terms of performance? I don't have any performance benchmarks. I'm not a Microsoft guy, so I really can't tell you numbers. But architecturally, I can tell you it's a whole lot more streamlined. It's one of those things. As they build new versions, it's going to get faster. I think this one, my personal opinion is this one will be faster just by the fact that I can totally not install modules that I don't use. So I go back to IIS 6, under ASP.NET under IIS 6, by default runs, for example, the passport authentication module. Well, nobody really writes passport applications anymore, but that module loads and runs every time. In IIS 7, you just don't install it and nothing's there. So the other thing that's really nice is if you get the x64 edition, it actually just runs natively just a whole lot faster. It allows you, even 32-bit apps under x64, unless you're doing something really, really funky, will just run faster because it has better access to more memory. There's a lot less garbage doing in the interpretation layer. So I'm sure on Microsoft.com somewhere they'll have some perf stats, but really at the end of the day, it depends on your application and what you're doing. There's so many wildcards in there. And so you can pull out tools like the Visual Studio Team Test, and you can run a load test and get the perf numbers off that. I think HP's got their Mercury load runner that will pull some information. You've got to test your own app. That's really the bottom line. If you've written bad HTTP handlers that don't do async requests, that will drastically affect your performance, and that has nothing to do with IIS. One of the best, if you're going to do any sort of perf testing under IIS, my advice is always baseline it with a static file. So do your load test against default.htm, and then go from there. Because what that's going to say is, here's IIS running at its most bare, and then now run your ASP.NET page. And you'll know this is what IIS can truly push through under this configuration. And then now here's the differential of me introducing my application on top of that. And that gives you really some great pieces of information. So I hope that answers the question. Question, yeah? Yeah.
We are using log4net in our application from web layer till layer.
Yeah.
So, okay. How do you compare performance-wise log4net versus the ASP.NET Tracing?
Sorry, log4net. I'm not quite sure in terms of the perf of log4net versus the system diagnostics. I know versus enterprise library, system diagnostics is a lot faster. Okay. And the reason is the enterprise library has a whole lot of build-up to deal with a bunch of situations. We're coming from enterprise library and we're dropping enterprise library. We just found it's like a sledgehammer when I just need a fly swatter. System diagnostics is, like I say, backing onto event tracing for Windows, which is a fairly performant piece of code. It runs throughout Windows. I mean, if you saw the query provider list, a lot of the major components are traced out through that. So again, I don't use log4net a whole lot, but the kind of common sense says that system diagnostics will probably give you as good of a performance, if not better, from that aspect. One of the neat things about backing onto system.diagnostics and not trying to reinvent the wheel is that my business logic layer can use system.diagnostics, my web layer can use system.diagnostics, and I can float it up and collect it into IIS, even though my business logic layer knows nothing about IIS executing on the environment. So if I use that framework, I'm able to leverage it right through my application, or if I choose to put a WinForms app on there, system diagnostics can read out of that. So that's what I like about system diagnostics.
I can see the advantage because we can use built-in Microsoft tools to trace, and the trace is built into the Microsoft, where log4net writes in a different sync. So it's kind of disconnected. What I'm saying is I can see the advantage of system diagnosis.
And so what do you want with log4net? You want to be able to write to like a SQL database?
We are writing into SQL database right now.
Yeah, you can do that with system diagnostics. Your trace listener, just because it's going through the IIS stuff, that's just one of the trace listeners. You can go to File, to SQL, to Email. You can write your own. Have it go to a printer if you want.
And I can use in even business rules or even data access layer also system diagnosis.
Yeah. So as far as rules and stuff like that, yeah, you can use the trace switches to control different aspects of how it traces out. You can set various verbosity levels there. So you could say all verbose things go to the SQL database, all errors go to email. You can kind of have that control inside system.diagnostics. In the past, kind of leading up to this point, what stopped a lot of people from system diagnostics is the lack of really good documentation and tutorials. And with IIS 7, there's changes afoot to try and put out more examples. There's also a great project, and unfortunately the name doesn't slips my mind, but send me an email and I'll send you the link. There's somebody that's basically filling in all the gaps around system.diagnostics and building on some great utility stuff.
A quick question. Is there any tools, third-party tools, you recommend for debugging, remote debugging a web server? Like we saw different ways of doing things using that command line utility. Is there any third-party tools I can directly connect to the remotely to IIS and just debug?
So when you say remotely debugging a web server, do you just want trace information, or do you want to set breakpoints and all that stuff in the code level?
Breakpoints is ideally good, but at least trace is also fine.
So tracing, all these tracing tools work remotely. I don't have to be on the web server.
Okay.
So I can set that up and connect remotely. There's also on codeproject.com, there's a guy that's built a really great, I think it's actually called Trace Tool.
Okay.
And it interfaces with Log4net, Entlab, System Diagnostics. And it's basically a console app that allows you to see real time what's actually happening on the server. I was trying to think what else is available. Yeah, that's pretty much it. I mean, what they're coming out with the next version of Visual Studio, not 08, but the next one is they're going to have a standalone debugger that you can put on a USB key. And it's a really lightweight debugger that will allow you to do remote debugging. But again, in some production environments, firewall rules, security, you can't do that sort of stuff. And that's where tracing comes into play. It allows you to get that information out without actually having to make a connection or open a firewall port or anything like that.
Okay.
So,
Thanks.
yeah, great questions. Any other questions here before I wrap up? All right. Oh, we got one more. Yep.
IIS 5.0.
Yeah.
And in that, huge transactions are happening, and sometimes it stops responding. And the only solution that we do is like we reset the IIS and then it starts working fine. Is this memory management kind of concern being addressed in IIS 7?
So, sorry, application IIS 5 randomly stops.
Yeah.
And you just recycle it and things go.
Yeah.
Bottom line, you got to start to figure out what the root cause is. It's not, those sorts of problems. It could be a number of things. It could be you could be running out of threads. You could be, over allocating your memory. So on IIS 5, there's not a lot of tools there to start digging into it. But I would start with Performance Monitor, look at the IIS process, and make a log over time of CPU utilization, all the ASP.NET counters, and any of the memory counters, and see what's growing over time. There's a couple of things that you want to watch out for. Just overall private memory growth. The private bytes are the things that can't be swapped to disk or shared out. The other thing that you want to watch out for are just the overall size of the ASP.NET thread pool. It is limited, so if you've consumed all the threads with long-running operations, and you need to recycle it to get things back up and running to make it responsive again, that's certainly a possible thing. It's either memory or threading that you've just eaten up all your threads with long-running operations. And in that case, I'd say your solution is, for the thread thing, is asynchronous everything. On the memory side, it's just analyzing what...
In IIS 6.0 or 5.0, number of requests that can be queued into that particular IIS server. Okay,
Yep.
Once that, there is also one configuration setting where after exceeding some those number of requests,
Yep.
that worker process will recycle.
Yeah.
And that's why maybe that can be the one of the reasons.
I look at that as, it's a good point. So he brings up in IIS, in 6 definitely, possibly 5, you can modify and do a lot of kind of recovery type operations where when the request meets a certain point or memory hits a certain point to auto recycle the pool. It's good, and I've used it before. Where it hurts is it actually cancels any running requests. So if I'm in the midst of waiting for a payment to go through and I'm checking out in a store and it recycles the app pool, I may actually lose my thing and I come back with a 500 error or something like that on the client side. So it's actually a really bad client experience. And I've only used it in cases where we're in the midst of debugging, we don't quite have a solution yet, and it at least saves the system admin from being paged every couple of hours to recycle the app pool. So I've used it as temporary workaround. And I'd say if you're filling up that request queue, it's either time to buy more servers or do some performance analysis.
Web garden or web farming would be great in such scenarios.
Yeah, web farms are perfect in that. And again, IIS 7 does a lot to make web farming way easier. There's a MSDN webcast on all the improvements around web farm stuff in IIS 7. I highly recommend it. If I look at, again, IIS 7, I said this yesterday if you weren't here, this is the thing that's driving Windows Server 2008. When you look at who is looking out there to buy Windows Server 2008, it's all about IIS 7 because they've improved the operations and the development side. Everybody wins with IIS 7. So it's really driving a whole lot of deployments out there. So if you're on IIS 5 today or 6 today, they've worked on compatibility. We'll talk about that in my next session in terms of what it takes to get up there. there are some gotchas, there's some things to watch out for, but overall it's not really a painful experience. You know, it's just a little bit of work and you can get up to IIS 7 and take advantage of all these great tracing tools and find out what's going on inside your worker process and what's actually happening to cause it to stop responding is a great example. Who knows, that could, you know, that may be a great little migration test. Spark up IIS 7, throw your app on it, see if you can actually get it to stop responding, and then pull the information out using some of these tools. So there's a few options there. So thank you very much, folks, and we'll see you in